data problems often involve a large number of heterogeneous data sources, and as data analysts, you might not be familiar with the data schema that comes with those data sources. This is really the variety aspect of the 5 V's of big data. Recall, we have volume, velocity, variety, veracity, and value. Now, in this lab, you will work with AWS Glue to perform an extract, transform, and load, or ETL, for a dataset. Now, AWS Glue is very similar with Amazon Athena. Recall in the last 2 sessions, or the last 2 lab sessions that we've had, we've been querying the dataset without it being ever removed from its source, which is the S3 bucket. In that same way, you can query with AWS Glue without it having to be removed from your data source. But the difference is with AWS Glue, you can create a crawler that could create the metadata and of course extract that data and build a database. You can also transform the schema and load the dataset into an AWS database. And after that, you can now apply your SQL statement and query it like we've always done. In this lab, you will learn how to use AWS Glue to import a dataset from Amazon Simple Storage Service or Amazon S3. You will then extract the data, transform its schema, and load the dataset into an AWS Glue database for later analysis, again by using Athena. So hopefully after completing this lab, you will be able to do the following: access AWS Glue in the AWS Management Console and create a crawler. Create an AWS Glue database with tables and a schema by using a crawler. Query data in the AWS Glue database by using Athena. Create and deploy an AWS Glue crawler by using an AWS Cloud Formation template. Review an AWS Identity and Access Management or IAM policy for users to run an AWS Glue crawler and query an AWS Glue database in Athena. You can also confirm that the users with the IAM policy can use the AWS command line interface or AWS CLI to access the AWS Glue database that the crawler has created. And finally, you can confirm that the user can run the AWS Glue crawler when the source data changes. Without further ado, let's start with our lab session. But before we begin with the tasks that we've mentioned, there are some prerequisite tasks that we need to do in order for us to continue with those tasks. We first need to go to S3 to create our 2 buckets. These buckets will contain the queries that we will be running in Amazon Athena. For the first bucket, let's name it Data Science Bucket, and because it's important for this to be globally unique, I'm assigning a random number which you should remember because we will be using it for our permissions. Go with the default settings and create the bucket. Once it's been created, create another one and let's name it AWS Glue Bucket, and just maybe append the same random number that you used with the data science bucket, and this will be our second bucket. This will contain our queries later on for years 1950 onwards. That's why it's called AWS Glue 1950-086295. For our second prerequisite task, we need to go to IAM and create the necessary permissions in order for us to run our queries later on and manage the access to our cloud formation template that we will be doing. The first thing that we need to do is to create a data scientist group, and this is important because we need to be assigning permission to an entire group, so when we create users, they will all have the same access. Skip with the permissions for now and we will be creating a user. So go to the users tab and create a user named student for Glue. So check the provide user to the AWS Management Console, and I want to create an IAM user, and of course the users must create a new password at next sign in. So go with this and click next. After that, you can assign it to the user group that we have just created by clicking on the group name of data scientist and clicking next. Review and create a user. It's a good practice to store the CSV file for the credentials of the users that you have created for future use. Once we have successfully created our users or a user, you can now go to the user group and click on the data scientist group, and you can see that the user that we have created, student for Glue, is now assigned to this group. Next, we go to the permissions. The permissions that we will be attaching to this data scientist group is a customized one, and a file will be provided in the link in order for you to attach this as an inline policy. So copy this file, go to the permissions tab, and go to add permission and create the inline policy. So to create an inline policy, choose the JSON file and paste in the JSON text file, the content of the JSON text file that was made available to you. Scroll down and take a moment to understand the permissions that we have attached to this policy. We can see there we have the S3, there is an explicit allow and explicit deny of some actions. We likewise have the Athena. Now take note of the data science bucket here. We need to change this file into the name of the buckets and the AWS Glue 1950 bucket that we have created earlier. So go to S3 and copy those file names. Replace them appropriately, the data science bucket with the data science bucket that you have created, the globally unique name for the data science bucket, and the globally unique name for your Glue 1950 bucket. You're free to name them however you want, but it must be globally unique. There's another portion where this 4 needs to be changed for 4 lines. So please copy the 4 lines and simply paste them over here. We have effectively given the data scientist group some access to our S3 buckets and the files or objects within it. Now name the policy as policy for data scientist. And after that, review the permissions that you have attached to this policy. You will see the explicit deny and explicit allow. This is a good practice, and go and create the policy afterwards. After that, we now have successfully created a policy for the data scientist group, and all of the users within that group will share the same permission. As a last task, let's create an IAM role to access the AWS Glue service. So click the AWS service here for step 1, and for the use case, since we will be using it to access AWS Glue, type in Glue and click next. After that, here we need to attach 2 policies that are AWS managed, as you can see in the type. So for that type, we need to attach the S3 full access, Amazon S3 full access, and the AWS Glue service role. After attaching these 2 policies, click on next and name the role as Glue Lab and create the role. We have now successfully created a role that we will be using later for our task in accessing the AWS Glue service. As a data engineer or analyst, you might not always know the schema of the data that you need to analyze. AWS Glue is designed for this kind of situation. You can direct AWS Glue to data that is stored on AWS, and the service will discover your data. AWS Glue will then store the associated metadata, for example, the table definition and schema in the AWS Glue data catalog. You accomplish this by creating a crawler which inspects the data source and infers a schema based on the data. In this task, you will work with data that is publicly available in an S3 bucket to do the following. First, to configure and create an AWS Glue crawler. 2. To run the crawler to extract, transform, and load the data into an AWS Glue database. 3. To review the metadata of a table that the crawler created. And 4. To edit the schema of the table. First, you will configure and create a crawler to discover the schema for the ghcn-d dataset and extract the data from it. So to do that, we have to go to AWS Glue. In the navigation pane, under Databases, choose Tables. Choose Add Tables using a crawler, and for the name, enter Weather. Expand the Tags optional section, and notice that this is where you could add tags or extra security configurations, but for now, we keep the default settings. Choose Next at the bottom of the page. Choose Add a Data Source and configure the following. The data source is S3, and the location of the S3 data is not within our own account, but in a different account. So choose in a different account, and enter the following path for the S3 path. For the subsequent crawler runs, choose Crawl All Subfolders and choose Add an S3 data source. Choose Next. In the next page, for the security settings, choose the Glue Lab IAM role that we have earlier created. For the rest of the options, go with the default and click Next. In the Output Configuration page, we will add a database. A new browser tab will open here, and for the name, enter Weather Data. Return to the browser tab that is open to the Set Output and Scheduling page in the AWS Glue console. And for the target database, choose the Weather Data database that you just created. So for this one, you'll have to refresh it. So refresh it, and you'll see the Weather Data. For the crawler schedule, just set the frequency for on-demand and choose Next. So confirm that your crawler configuration is similar to what you're seeing on the screen. Choose Create Crawler after confirming. To perform the extract and load steps of the ETL process, you will now run the crawler. You can create AWS Glue crawlers to either run on demand or set a schedule. And because you created your crawler to run on demand, you must run the crawler to build the database and generate the metadata. So go to the crawlers in the navigation pane, and to run it, just choose Run after selecting the weather crawler. And as you can see right now, it's running. Wait for the status to change to ready before you move on to the next step. In my case, this will take around 2 to 3 minutes. Now, AWS Glue creates a table to store the metadata about the ghcn-d dataset. And after this, we will inspect the data that AWS Glue captured about that data source. After a few minutes, the state of our crawler will show ready, indicating that it has finished with its run. A few notes with the dataset that we have just crawled. The Global Historical Climatology Network Daily, or the ghcn-d, is an integrated database of daily climate summaries from land surface stations across the globe. So you'll see here in the summary of the day format are the variables that we will encounter in the data catalog: the ID, year, month, date, element, data value, M flag, Q flag, S flag, and the observation time. To review the metadata that AWS Glue created, under the databases, choose the weather data database, and in the table section, choose the by year link. Review the metadata that the weather crawler has captured as shown in our video, and of course the schema lists the columns that the crawler discovered in the imported dataset. You'll see that in our examination of the dataset earlier that you'll find these following columns to be the one to have been imported by our crawler. Now, you will edit the schema of the database, which is part of transforming data in the ETL process. To do that, in the Actions portion, click Edit Schema, and you can proceed to edit each of the columns as follows. So for the ID, change it to Station. The date remains the same. For the element, change it to Type. For the data value, change it to Observation. And for the three flag values, simply remove the underscore. Finally, for the observation time, change it to just time. After that, save as new table version. The schema for the table should look like what you're seeing now in the video. So we're done with task 1, where in this task, you use the console to create a crawler in AWS Glue. You directed the crawler to the data that is stored in an S3 bucket, and the crawler discovered the data. Then the crawler stored the associated metadata in a data catalog. By using a crawler in AWS Glue, you can inspect a data source and infer its schema. Now that you created the data catalog, you can use the metadata to query the data even further by using Athena. So in this task, you will complete the following steps. First, configure an S3 bucket to store the Athena query results, and we have done the prerequisite task for this. Preview a database table in Athena, create a table for data after 1950, and run a query on selected data. In the navigation pane under the databases, choose Tables. We're now at the Tables portion. Choose the link for the by year table, choose Actions and View Data. When the pop-up appears to warn you that you will be taken to the Athena console, choose Proceed. The Athena console opens. Now we have to go to Settings and change the location of our query result by going to the Manage Settings and choose the Browse S3 portion and choose the Data Science bucket that we have created earlier on. Aside from the location of the S3 bucket, leave the other options in its default state and choose Save. Now, in the Editor tab in the Data panel on the left, notice that the data source is the AWS Data Catalog, and the database should be the weather data. Now, in the Table section, choose the ellipsis icon for the by year table and then choose Preview Table. You should have the result similar to what you're seeing on the screen right now. Notice the runtime and the amount of data that was scanned for this query. As you develop more complex applications, it is important to minimize resource consumption to optimize cost. Now, we have to do another step for our S3 bucket. For the Glue 1950 bucket that we have created, we have to put in another folder, and let's name it Lab 3. The reason for this is that we need to be getting the S3 URI, and it's only possible if there's a folder inside it. Now, copy the name of the bucket, the AWS-Glue 1950, because we will be using that for our next query. And go again to the Athena console to perform the next query. For the next query, we will create a table for data after 1950. So the query will be as follows. Open a new tab and type the following query to create this table, which we will call late 20th. Pause the video at any point in order for you to follow the query that is being written. After the query runs, the runtime and data scan values should be similar to what you're seeing on the screen. Please take note that the format that we have used for this particular query is the Parquet format, and as noted, it should be more efficient as compared to the other formats that we have queried before. To preview the results in the table section to the right of the late 20th table, choose the ellipsis icon and then choose Preview Table. The results should be similar to what you're seeing on the screen. And now that you have isolated the data that you're interested in, you can write queries for further analysis. So we'll create a new query, open a new tab rather in the editor, and then first create a view that only includes the maximum temperature reading or the Tmax value. So the following query should be what you should type in order to get that. To preview the results in the view section to the right of the Tmax view, choose the ellipsis icon and choose the preview view. So the results should be similar to what you're seeing on the video right now. And let's try to run again another query in a new query tab. So open a new query tab and type the following. The purpose of this query is to calculate the average maximum temperature for each year in the dataset. The result displays the average maximum temperature for each year from 1950 to 2015. Are the values similar to what you're getting? Remember that when you create queries with Athena, the result of the query must be stored back in the Amazon S3. In a previous step, we specified the location in Amazon S3 where your queries are stored. And when using AWS services, you generally pay for what you use. However, because you reduce your query to only 3 columns of temperature data from 1950 through 2015, you reduce your cost for your storage. Also, because you arrange the query data in the columnar format of the Apache Parquet, the time that it took to perform the queries in this task was reduced, resulting in less cost, as you use, of course, fewer computational resources in Athena. Now we're done with task 2. In this task, you learned how to use Athena to query tables in a database that an AWS Glue crawler created. You build a table for all the data after the 1950 from the original dataset. And of course, we also use the Apache Parquet format to optimize the Athena queries, which reduced the time that it took to complete each query, resulting in less cost. Of course, after isolating this data, you created a view that calculated the average maximum temperature for each year. AWS Glue integrates with the original dataset stored in Amazon S3. AWS Glue can create a crawler to ingest the original dataset into a database and infer the appropriate schema. Then, you can quickly shift to Athena to develop queries and better understand your data. This integration, of course, reduces the time that it takes for you to derive your insights from your data and apply these insights to make better decisions. In Task 1, you use the console to create an AWS Glue crawler to inspect the data source and infer a schema. However, you may work with many datasets in different AWS accounts, which may include development, test, and production teams. Therefore, it would be helpful to reuse crawlers across these environments, especially when the new data is added to the dataset. it will also be helpful to use the AWS CLI to run the crawler. If your crawler runs more than once, perhaps on a schedule, it looks for new or changed files or tables in your data store. The output of the crawler includes new tables and partitions that were found since the previous run. So in this task, we'll only have one major task, which is to create and deploy a crawler by using CloudFormation. In the search box next to Services, search for and choose IAM to open the IAM console. In the navigation pane, choose the roles. Choose the link for the Glue Lab role. The ARN is displayed on the page in the summary section. Copy the ARN to a text editor to use it in the next step. This next step involves us going to the Cloud9, which we have used in the previous 2 lab sessions. If you have not deleted your Cloud9 environment, then proceed to use that environment. Otherwise, create a new one with the lowest EC2 instance. So for this one, since I have deleted it, I will create a new environment, Data Engineering, with T2 Micro 1 instance. And after that, open the IDE. This will take some time. A new browser tab opens and displays the AWS Cloud9 IDE once it's done. Now in the AWS Cloud9 IDE, choose File and New File here, and copy and paste the following code. This code block uses the sample AWS CloudFormation template for an AWS Glue crawler for Amazon S3, which is found in the documentation. Save the changes to the template file as gluecrawler.cf.yaml and examine the code to see what is being created. In the file, replace the Glue Lab role ARN with the ARN for the Glue Lab IAM role. Look for that line that starts with role, which is around line 27. Now open a terminal and let's validate the CloudFormation template. Run the following command in your AWS Cloud9 terminal. Please feel free to pause the video to type the following code. If you receive an error that says YAMLs not well formed, check the value for the name of the Glue Lab role. Also check the tabs and spacing for each line. YAML documents require exact spacing, and the parser will encounter errors if the spacing doesn't match. Now, if the template is validated, the following output displays. Please do not go to the next step until the template is validated. Now, you will use the template to create a CloudFormation stack. A stack implements and manages the group of resources that are outlined in a template. With the stack, you can manage the state and dependencies of those resources together. Think of your CloudFormation as your blueprint. Then the stack is the actual instance of the template that is registered in AWS and actually creates resources. To create the CloudFormation stack, run the following command as seen in your screen. Now notice here, the command will include the capabilities parameter with the capability _named _IAM capability. This is because you are creating the following resources with custom names which affect the permissions. If the stack is validated, the CloudFormation ARN displays in the output similar to what you're seeing on the screen. To verify that the AWS Glue database was created in the stack, run the following command. The output should be similar to the following. To verify that the crawler was created in the stack, run the following command. The output should be similar to what is seen on the screen. To retrieve the details of the crawler, run the following command. The output should be similar to what you're seeing on the screen. Review the response. Notice that the state of the crawler is ready. This means that the crawler is deployed, but it hasn't run yet. In this task, you learned how to integrate an AWS Glue crawler into a CloudFormation template. You also learned how to use the AWS CLI within the AWS Cloud9 terminal to validate and deploy the template to create the crawler. With the template, you can use or reuse the crawler in other AWS accounts. This task involves us reviewing the policy that are associated with our data scientist group. So go to IAM and click the user group for the data scientist. Go to the permissions tab and click on the policy for data scientist. Review the permissions that are associated with this policy and notice that the permissions provide limited access for only the Athena, AWS Glue, and Amazon S3 services. If you want to look more closely with the details of the IAM policy, you have to choose the JSON option. And in the JSON policy file, you can see the allowed and denied actions, including which resources the users can perform actions on. Now that we have reviewed the IAM policy, we will use it to test another user's access to the AWS Glue crawler. We will also test that user's ability to use the crawler to extract, transform, and load data from a dataset stored in Amazon S3 into an AWS Glue database. This task is a bit similar to our task 3. We have to go to users and go to the permissions that we have assigned for the student for Glue and go to security credentials. In here, we need to create the access key for this user. Choose command line interface and accept the confirmation and click on next. Provide a description tag value, maybe Glue practice, and create the access key. Once you have the access key and the secret access key, copy them and put them in a safe space or maybe your text editor for now, as we will be testing this particular user's access. So this is the student's user's access key, and we will test that if we have deployed the CloudFormation template, if they themselves can access what you have created. Once we have copied the access key and the secret access key, we will turn them into bash variables. For AK, we will input the value of the access key, and for the SAK, we will input the value of the secret access key. These variables will help us test whether the user with these credentials can access the CloudFormation template that we have created. To test whether our user can perform the list crawlers command, we will run the following command. Feel free to pause the video to copy the exact command. The output will be similar to what is displayed on the screen and what we have seen earlier when we tried it ourselves. Now, to test whether the same user can access the getCrawler command, we can simply modify the last command that we've entered to resemble the getCrawler command. Again, the output will be similar to what we have seen earlier. Now, to test whether the same user can run the crawler, we modify the last command to resemble the start crawler command. If the crawler runs successfully, the terminal doesn't display any output. So, to observe the crawler running and adding the data to the table, navigate to the AWS Glue console. here you can see the status information for the crawler. You can see that the CFN crawler here is now running. When the status changes to ready, the crawler is finished running. Return now to the AWS Cloud9 terminal. And to confirm that the crawler is finished running, we run the following command. It's with the get crawler command as well. The output is similar to what's displayed on your screen. And notice that the last scroll section is included and the status in that section is succeeded. This means that our user with the credentials that we have generated was able to access the AWS Glue service. So this effectively ends our task 5, and congratulations, you have learned how to create an AWS Glue crawler manually and by using the CloudFormation so you can deploy it to users with a secure IAM policy. Because the crawler is in a CloudFormation template, you can reuse the template to create and deploy the crawler in any AWS account and change the parameter as desired. So as data engineer, you will be able to do this and give the access to your fellow teammates, data scientists, or data analysts. In this lab, we've learned how to efficiently manage and query large and varied data sets using AWS Glue. Now here's a brief recap of what we've learned so far. We've had an introduction to AWS Glue where we've learned that AWS Glue simplifies the process of extracting, transforming, and loading, or ETL, of the data, and it likewise helps infer schemas automatically, reducing the manual effort. We've also learned how to create and use crawlers. We created an AWS Glue crawler to discover the schema of a dataset stored in an Amazon S3 bucket. This process involved configuring the crawler, running it, and reviewing the metadata it generated. We've also learned about data transformation and loading. We've transformed the schema of the data and loaded it into an AWS Glue database, making it ready for further analysis. Again, we've also queried using Athena. We use Amazon Athena to query the data stored in our AWS Glue database, and we likewise optimized our queries by storing data in the Apache Parquet format, improving performance and reducing costs. We've likewise achieved automation with CloudFormation, where the CloudFormation template that we have created to automate the deployment of the AWS Glue crawler is ensuring that it can be reused across different environments. And lastly, specifically for this lab, we reviewed IAM policies to ensure secure access and permissions for running crawlers and querying data in Athena. By the end of this lab, you should feel a little bit more confident with using AWS Glue to manage large data sets, perform ETL, and seamlessly integrate it with the other AWS services like Amazon Athena and Amazon CloudFormation. Now, the skills are actually very crucial for you to handle big data scenarios in the real world. Now, thank you for participating in this lab, and hope you've learned a lot, and happy data wrangling.